Hello, let's take a look at our Unit 7 practice test and see if we can figure out some of these problems here. So what we're talking about is making the answer key for our Unit 7 practice test. And in this first question, what we're trying to do is we're trying to solve for solve for m, and that's what we're looking at here, specifically when the value of y is 3. So we're looking for an x value when given a specific y value. Before we do that, we do have to find our constant of proportionality. So because we're looking at an inverse variation, and they say that in the directions up here, an inverse variation will always look like y equals k over x, or another way to think about that is x times y equals k. Now the reason why that form is helpful is that we can replace both x and y with a paired piece of data. So I'm going to pair 2 and 18 to find that value of k. So when we do that, I have 2 times 18 equals k, which gives me a value of 36. That number I can use both forward to move to find that value that we were looking for up here, this value of m. So let's write out our equation. X times y is equal to 36. Now they've also have given us this specific y value, 3. So I'm going to plug that in for y and use that to find that missing x value. And so when I divide both sides, I end up finding that x is 12. Answer is D. Moving on to the next problem. Story problem here, application, but again, we're going to kind of do the same sort of thing. So let's make sure we read through this thing carefully. For a given set of rectangles, the length is inversely proportional to the width. So again, let's write that L out. L times W is equal to some constant of proportionality. Another way of saying that again, or we could write L is equal to K divided by W. Either way we want to write that is fine. It says in one of these rectangles the length is 12 and the width is 6, so let's use that information. So I'm going to drop a 12 and a 6 in here, and when I multiply that out, I end up getting 72 is that constant of proportionality. It then says for the set of rectangles, calculate the width of a rectangle whose length is 9. So let's rewrite this again. L times W equals 72. But let's take advantage of this specific given information. So when we drop that in, we have 9 times W is 72. And then if we divide out, it looks like W is 8. All right, moving on to the next question. What we're looking at here is it says which equation shows that P varies inversely as Q. So one way to look at that would be P equals K over Q. Another way to look at it would be P times Q equals K. Both of those are models of inverse variation. And for me, this value, this letter B, holds for that. So we have P times Q is equal to some number, and that number is 10. Okay. All right, moving on to number 4, we've got a problem here where we've got some addition as well as some division. So what I'm going to do is I'm going to jump inside this quantity first. So I'm going to add those two expressions together. So I'm going to turn that 1 into x over x plus 1 over x. And I'm going to leave the right side of the expression alone for a second. If I add the left side, I end up getting x plus 1 over x. And we're dividing that by x plus 1 over x squared. Now, keep in mind that when we divide, we're always supposed to multiply by the reciprocal, but the reciprocal of the right-hand expression. So I'm going to turn this into a multiplication problem. And now comes the part everybody loves to cancel out. So I've got an x plus 1 and an x plus 1 I can cancel. I have one individual x that I can cancel with this x. So when I've done all that reducing, what I'm left with is x over 1 or just x. So what I'm looking for here is D. All right, next one. We have a division again. So I have an x minus 1 over x times, I'm going to take the reciprocal of this expression. So the x squared is going up top. The x squared minus 1 is going on the bottom. Before I do any of the simplifying or the reducing, I am going to factor. So I'm going to take that denominator and turn it into an x plus 1 and an x minus 1. And this will allow me to do some canceling. So I can cancel out an x minus 1. I can cancel out one of these x's. And so what I'm left with is just an x up top over an x plus 1. That's what I would call the most simple answer for this one. So we're going with A. All right, on to number 6. Again, another division problem, so this one looks a little different than the previous, but pretty similar. So we're going to take x plus 1 and divide it by x minus 1. We are going to multiply by 1 minus x over x squared minus 1. Now again, we do have some factoring to do. So I'm going to rewrite the left-hand side because there's no factoring to do there. The bottom right is, again, the same difference of squares that we were working with before, but the top right we can factor into -1 times x minus 1, and that's relevant because it's going to allow us to cancel some things. So I can get rid of an x minus 1 and an x minus 1 here. I can get rid of an x plus 1 and an x plus 1 here. And it looks like what I'm left with then is a -1 over x minus 1. That's one way to write the answer. A different way would be to write it out as 1 over 1 minus x. And either one of those forms would be appropriate. And that actually is the answer that we have here for C. Okay. So let's keep moving then if we can. So we've got a multiplication problem here. Pretty straightforward. The pain in this one is that we do have a lot of factoring to do. So the top left I'm factoring into an x minus 3 and an x plus 2. The bottom left factoring I'm factoring it into as an x minus 2 and an x minus 1. The top right has a GCF, which is nice. I'm going to go ahead and pull that out. I've got an x squared minus a 3x plus a 2. That will factor further. And the bottom right does factor into an x minus 3 and an x plus 1. I am going to go ahead and factor out this top piece here, this piece, because it does factor further. So I'm going to factor that into an x minus 2 and an x minus 1. So I'm going to go ahead and get rid of that. All right, on to the canceling. So I've got an x minus 2 here, an x minus 2 here. I've got an x minus 3 and an x minus 3, and an x minus 1 and an x minus 1. So when all is said and done, and this is kind of the important piece, make sure that you highlight this part. We've got 1, 2, 3 things that are left over. Those 3 things I can write out 2 times the quantity x plus 2 on the top, and I've got a quantity of x plus 1 on the bottom. So when I look through at this, let's see, it looks like I'm looking at A because they distributed this in. Another way to look at it would be 2x plus 4 over x plus 1. Okay, let's keep moving. On to subtraction. This should be the most straightforward problem we have all day. 4 minus 3 is 1 over 5x. The denominators are the same, which is what allows us to do the subtraction. So 1 over 5x, that's the value of A. This one's a little bit more difficult, a little bit more work to do. We do have denominators here, but they're not the same. So I have an x minus 5 and an x plus 5. So we have to multiply by our values that are going to give us our least common denominator. The right side needs an x plus 5 over an x plus 5. The left side needs an x minus 5 over an x minus 5. And we are going to have to multiply these out. So looking at this expression, then we now are looking at 3x minus 15 plus 4x plus 20, and that's all over the denominator of x plus 5, x minus 5. Got a little bit of work to do here, so I've got a 4x and a 3x, that's going to give me a 7x, and I've got a negative 15 and a 20, so that's going to give me a positive 5. And when all is said and done, this is what I'm looking at for my final expression. So I've got 7x plus 5 all over x plus 5, x minus 5. Now that doesn't seem to be one of the answers, but again, if we multiply out this denominator, if we FOIL this thing out, we do end up getting C. All right, moving on to problem number 10. Problem number 10 does have common denominators, so somebody's smiling on us, trying to make this easy. But do keep in mind with subtraction, we do have to distribute the negatives. So 3x minus 2x is in fact just an x. And then again, don't forget, you are saying 2 minus a negative 3. So 2 minus a negative 3 is going to give me a value of 5. Now, Most students would look at this and say, oh, nice job, we're good. We do have a little bit more work to go because the bottom does factor, which allows us to do some canceling. So the bottom factors into an x plus 5 and an x minus 5, and then we'll be able to cancel out these two common factors. So we're looking at 1 over an x minus 5, which I believe is B. All right, let's keep moving. Problem number 11. So we have some factoring to do before we do any of the subtraction. So let's first factor the left side denominator. That's going to factor into an x minus 2 and an x minus 3. The bottom right is going to factor into an x plus 3 and an x minus 3. So in looking at this, what they have in common already is they have this x minus 3 in common. But what they're missing, what they have that's different, is they have an x plus 3 on the right-hand side, but an x minus 2 on the left-hand side. So we're going to have to give this thing some thought before we get our common denominator. So what the right-hand side is going to need is it's going to need, and I'm going to change color here just to make sure that we see this is kind of a key step, it's going to need an x minus 2 over an x minus 2. The left-hand side is going to need an x plus 3 over an x plus 3. And again, we are going to have to do some foiling here, so it's a little bit of work. So I'm going to FOIL the tops. I'm going to take this expression times this expression. So I've got an x squared, let's see, plus a 4x plus a 3. On the right-hand side, I will have to FOIL this expression with this. So I've got an x squared plus a 2x minus an 8. And on the bottom, I have those three expressions. So these three things, I am going to try and squeeze that in just so we can kind of pay attention to our work as we go. So I've got an x plus 3, an x minus 2, and an x minus 3, and the same three things on the on the right-hand side. Now again, when we are subtracting, this is a place that students sometimes will make mistakes. Don't forget we are subtracting x squared and x squared, so those two things will cancel. The next thing that we are subtracting is we're saying 4x minus a 2x. So 4x minus a 2x is in fact just a 2x. And then we're saying we've got a value of 3 minus the value of a negative 8. So careful with your signs there. So 3 plus 8 is really what we're looking at, which is 11. All over an x plus 3, an x minus 3, and an x minus 2. All right, so we're looking at that, and we're looking for a 2x plus 11 on the top. It looks like that A is our winner there. Okay. All right, now what we're looking at here, what is the solution? This is a little bit different. We're not adding or subtracting or multiplying, dividing. We are, in fact, solving. Recall that when we're solving, we're going to do some cross multiplying. So I'm taking k plus 4 times 3. So I'm going to write that out. And that should be equal to taking 2 times k plus 9. So when we set this equal to, we're setting the top and the bottoms, multiplying them crisscross and setting those equal to each other. So 2 times the quantity k plus 9. So when I multiply this out, I've got a 3k plus 12 is equal to a 2k plus 18. Subtract 2k, and it looks like we are looking at k plus 12 is equal to 18, which means that k is equal to 6. And we're going with option C. All right. Next one's a little bit more work. We do need to factor this denominator. We've got an x plus 3 and an x minus 3. And it looks like, if we're trying to compare terms, that we have an x minus 3 here and an x minus 3 here, but we don't have anything here that would be that in common. So when we're looking at what each of these terms needs in order to have a common denominator, the right side is going to need an x plus 3 over an x plus 3. The middle term is going to need both. It's going to need an x plus 3 and an x minus 3. And the left side thing, it doesn't need anything. So keep in mind, when we do this, when we get a common denominator amongst all pieces, we can just make an equation out of the numerators. So the new equation we're sort of seeking to create is really this plus all of this stuff is equal to both this times that. So that's what I'm going to write out in my next step. So I've got 30 plus x plus 3 times x minus 3 is equal to 5 times and x plus 3. And I've got a little bit of work to do here. So I've got some foiling on the left and some distribution on the right. So 30 plus x squared minus 9 is equal to 5x plus 15. Combining some like terms, moving some things over to the left, I'm looking at x squared minus 5x. This 30 and this minus 9 is going to give me a 21, but then I'm going to subtract another 15 from it. So it looks like I've got a plus 6, which actually works out for factoring. So I'm looking at x minus 2 and an x minus 3. So what we're looking at for solutions are x equals 2 and x equals 3. So we might be tempted to go with option A, but do keep in mind that we do have a restriction, and it's because of this term. X is not allowed to be 3. So we're going to say thanks but no thanks to this solution that is an excluded value. It is an extraneous solution. So we are going to say that our only answer is 2, hence B. And I think that's it for our practice test. Hope that helped, and obviously if you have questions, always ask them.